In this tutorial we are looking at congruency. For shapes to be congruent, it means that they are the same. Now for them to be the same or congruent, they need to have or they need to follow one of the following rules. Side, side, side. That is to say, three sides of your shapes are exactly the same length. So side, 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 all of those sides. So this side is the same as this, and so on. Next is side, angle, side. So that is to say, if we have our triangles like this, we need this side, this angle, and this side to equal a side, angle, and its next side, in that order. So side, and then the angle, and then the side. So that's the angle sandwiched between two sides. Our next rule, angle, side, angle. So again, if we were to look at two triangles, that's to say this angle, this side, and this angle need to be identical to an angle, a side, and an angle in that order. And the final congruency rule is a right angle, hypotenuse, and then a side. So this is applying to typically shapes that involve a right angle, the hypotenuse, and then either of the sides, right angle, hypotenuse, and then a side. So let's see how to put this into an exam question and how to use these rules. Typically these questions are 3 to 4 marks. AOC and BOD are diameters of a circle. So AOC and BOD are diameters of a circle. Now we have to bear in mind they always tell us things for a reason. Prove that triangle ABD, so we are now looking at our triangles. I find the best way is to highlight each of your congruent shapes, so A, B, D, and D, C, A. So this involves a little bit of circle theorems as well. So AOC is a diameter. So what we know about diameters from circle theorems is that angles in a semicircle are 90 degrees. So that is to say angle CDA and angle BAD are 90 degrees because angles in semicircles are 90 degrees. And we know it's a semicircle because we have a diameter. So what we've got is an angle, or we could call it a right angle. Next, what we can see is AC and BD are equal. AC equals BD as they are both diameters to the circle. Now they are the angles opposite the right angle. So we could call that a side, or we could call that the hypotenuse. So what we've got is right angle, hypotenuse. Now we just need to prove another side is equal, of which here we can see they are line AD is highlighted in both yellow and green. So AD common to both ABD and DCA. So therefore that is the side. So therefore right angle, hypotenuse, side is the rule that we have proven, and that's our 3 marks. Let's try one more. PQ equals PR, and S is the midpoint of PQ and T is the midpoint of PR. Prove that triangle QTR, so triangle QTR, is congruent to triangle RSQ. What we can see straight away is our side of QR is highlighted in green and yellow, which means it's common to both. So you'll notice once you get started with some of these exam questions, they're all very similar wording. So what we've got there is a side. So this side we have proven to be the same. Next, what we can prove is TR being equal to SQ. Why? Well, if PQ is equal to PR and points S and T are the midpoints, they must be the same length, therefore side. So all we've done there really is just reworded what they've told us in the question. So we've got a side. Now we could prove that QT and SR are both equal and use the side. But what's even easier than that in this one is to use our side angle side and our side angle side. Reason being is because they've told us PQ and PR are equal, which means we have an isosceles triangle to which those two angles at the bottom are equal. So this is to say PQR is equal to PRQ. So just make sure you understand how to label an angle. You could even use the little hats over the letter in the middle to show that's where your angle is. Reason being PQ is equal to PR, therefore you have an isosceles triangle to which those base angles are equal. So we have an angle, and that is side angle side. Make sure it's in that correct order.